the activity of your operator, then it's a boolean.
Okay.
So a field basically has addition and
like
multiplication. You just call that for ease because it's all built off like
that's
fields and complexes and whatever.
I have one
Those
paper
are
due
both
this Friday and then the
abelian.
portfolio
Like
due next week. So
those are both commutative operations, and it's a group with respect to
Real
both.
dead week is
Okay, so wait, so say that again. What do you mean when it?
a real dead week should
group
have
that
absolutely
was
nothing to do with
Isn't there? You said there's
You can
three
define a
basic
different
basic
operation,
that's
and
what-
like the same set wouldn't be a group with respect to that operation.
No, you end up with these professors who
So you can start with the
end
group,
up
you
3
define an
weeks behind,
operation,
and
and
then
then
they're
it
like,
doesn't work.
hey,
Then it's not
we
a
were so
group.
far
Then it's
behind,
not
we're
a
gonna
group.
try to
Right.
get everything
It's
done
just
this
a
week.
A field is like a super group.
I mean, I know.
So you
She ended
basically,
up like 3 weeks behind.
so this is
and
just
she
saying
had
that you
us
take
doing
like,
3
you know,
chapters during that week
two
last
things in your field, do something to them, and you get something back in your field. So that's like all that is. So addition, right, is an abelian group, so it's, right, the thing has to be associative since it's a group, and then the abelian means it's so it doesn't matter.
Really,
like,
our geology finals.
You just call it zero, or like the identity element
Yeah.
0, and then with
Did
multiplication,
you,
you just call
I
the,
took it years ago.
the identity element 1. But like with multiplication, you just have to take out
Yeah,
0
Robert.
because it's not a group. If you include
That's
that,
risen. I know.
Uh,
The short kind of round guy.
because 0
Okay,
times
you
anything
can't-
just
yeah,
gets
yeah.
0 back, so like that
Yeah.
includes everything.
He puts out.
Is there any connection to this field
What
to
was
the
it?
physical?
You have all the tests, right?
Yeah,
Because it's multiple choice.
Yeah.
Just memorize every answer.
it
Well,
works to a point,
Like an electric
because he changed up his testing method and had to
Is there any
increase the amount of
direct
questions
connection, or is
per
it just
test.
sort of?
Okay,
I
well,
don't
like,
know.
you have like old tests
The
and
test
Vector fields are fields, kind of.
I took it with
okay,
two of
well,
my
it's-
friends.
it's
It's literally just the night
It depends
before,
on what you
memorized every
define.
answer in every test.
Okay.
Multiple choice.
Yeah, because it's 100 questions.
And
so-
then we
Yeah,
all
it's
got
cross would not
99s.
Yeah, no, it's 75
Okay,
questions.
well,
No,
thank you
that
for
would be-
continuing
back up.
investing your time into this course of certain level of importance. So our sufferings come to the end very soon. So unless there will be deep complaints, we will stop seeing each other this week. Well, if someone wants, we can keep meeting, but there will be no obligation. So 4 meetings total, including today. And most interesting will be Friday with presentations. So if you have an idea what it will be, just start working on it, and the rest is, so to say, optional or secondary. I would appreciate if you send the slides on Thursday midnight, so that everything will be loaded here and Friday will go smoothly. The room is reserved for an hour longer, so it will. I do not believe that we will be able to fit into 15 minutes. So it will go longer, and I probably will send you a list of who will speak after whom. So if there is a like life and death schedule conflict, we'll just move in such a way that those who need to leave earlier will be presenting earlier. Last time I will be able to help with the project is Wednesday night. So I will have a lot of wish to help on Thursday, but I will not be in the city. I need to be on travel to thesis defense in another state, and I will be driving from 6 a.m., then attending and then driving back. So plan, if you need any help, express it before. Thursday, although it is one day before presentation, I will be just not available physically. Many thanks to 92% of the class. Well, by now probably 96, and I'll check. Well, maybe in a minute it will be 100%. So the chapters of your reports are already in processing for booklets, so hopefully you will see them on Friday. If you suddenly realize that you want to change something, do not hesitate, but it is no required. What you have is already good. But if you are a perfectionist and you come up with an idea, there could be last minute change option. So Wednesday night lab is for tightening the loose ends towards presentations. If you are not sure about something is incomplete, something can be improved, please come. If you're 100% sure, then just relax and accumulate energy, strength. And last thing that I fear to forget to mention, please select one of the most representative runs of your code with your parameters and upload to YouTube and send me the link. As, you will need it anyway for your presentations, because in the relatively squeezed time, it is much easier to show movie rather than explain by words. And I plan to include it into the booklets in the same way as you saw from last year's. Okay, done with projects. Now you can lean back and relax. The subject to present is important, helpful, critical, but there is so small amount of time that we will not be able to go into anything in depth. So it will be more like a fairy tale to entertain you. So who we are, what are we doing, where we are in the class material. Well, of course, this ambitious plan will never come. This will never come. In today's meeting, I will try to squeeze material of 2 weeks. And on Wednesday, I will try to squeeze material on maybe 1 week. So today, I'll tell as much as I can about spin. And on coming Wednesday, I will share some stories that 3 or 4 of you would find most near and dear to your heart based on your projects. Some of the projects were dealing with multiple potential energy surfaces and with Marcus theory that was declared as a word, but we never were exposed to it. So I will do my best effort to deliver as much as possible about transfer reactions between different electronic states with reorganization of potential energy surfaces. And on Wednesday, I'll try my best to deliver the key feature of molecular spectroscopy. You have known, you were aware just as a little persons about the stuff that we didn't cover in the course, but I never doubt for even a second that you are aware of the hydrogen atom spectra, which are, main feature is that they have very linear shape, that they're instead of continuous and distributed spectra, they have very narrow lines. Right? And any atoms, if we scratch the white stuff from inside of the fluorescent lamp, it will be not fluorescent anymore. It will emit something greenish, purplish. And if one takes spectrum of emission of the mercury in this tube, there will be also few lines. So any atomic spectra are line-wise, and if you were ever exposed to molecular spectroscopy, even if you do not touch solids and non-materials, they are of very distributed line width, and their shapes are non-standard. You cannot describe spectra of molecules just as set of lines that do experience broadening. There are shapes like palm with several subpeaks, and they are offset for absorption and emission from main frequency of electronic transition. So there is a very specific influence of nuclear motion onto spectra of molecules. There is a phenomena of Stokes shift, and there are shapes of molecular spectrum. I keep an ambition to cover it on Wednesday. And practically, for those of you who touched this area in part in your projects, this has a little of technical benefits. So if we judge your writings formally, without any mercy, then formally a paper, if it has some computation, should explain which equations are solved. We all know it's Schrödinger equation. Forget which solution, but then you need to formulate the Hamiltonian of your system. And I, at my time, I did a great head throw off feeling when trying to put a Hamiltonian when there is not one potential surface but two of them. So if you feel comfortable and or if you without knowing it, or if you know how to formulate this Hamiltonian, then you are lucky. But just in case, I will keep an ambition to cover this issue on coming Wednesday as well. So how to formulate a Hamiltonian when we have more than one potential simultaneously. So you already practiced quantum dynamics. You got the results. You even wrote a paper on this. But how to express a Hamiltonian would be a nice thing to cover to round up what we do in class. Again, don't concentrate, do not take notes, lean back. There will be nothing serious. The only important thing is presentation. So what is the connection between ambitious plan for Wednesday and today? The electronic transitions, which are key parts for molecular spectroscopy, are described by same mathematical tools, especially if you're looking for transition between just pair of levels, like occupied and unoccupied molecular orbitals. The algebra of operators, the style how the future is predicted, how the expectation values are evolved in time, are identical to mathematical tools for describing spin, which is internal angular momentum that responds to magnetic field. And I don't care about spin. I do not like spin. But math that we get from looking at a spin is extremely helpful for Stokes shift, Marcus theory, Frank quantum factors, molecular spectroscopy, things that physical chemists must love. And some of you are or will be exposed to nuclear magnetic resonance, and then voluntarily or involuntarily you will be exposed to the concept of spin and its consequences on properties of material. So in between, this is recall from last non-project lecture, which was long ago. So between these two lines, there is like 10 intense math pages of textbook. So I kind of goofed up of not showing it. Hope you're not regretting. But the consequences of rigorous study of the angular momentum is in two brief statements. Rotations take discrete values of angular momentum. And angular momentum has direction. I didn't surprise anyone. This is kind of trivial. and the higher the energy of rotational motion, the longer the vector that represents rotation around this vector. But the length and the direction of this vector is allowed to take only specific values. So if you summarize quantum mechanics of angular momentum in, I would say, kindergarten level, then it was what I tried to say. Length and speed of rotation and direction of rotation take discrete values. Good. The higher the energy, the longer this vector. And in more advanced chapters of quantum theory, one can consider several objects rotating simultaneously and adding together energy of their rotations. And then those vectors experience simple rules of vector addition. So you can just take, if there is several things rotating inside, if you do not speak about atoms and molecules, the best example of adding angular momentum, which we'll not cover here, is quadricopter. So it has several propellers, and it keeps stabilized because two of them rotate one side to another, therefore it's stable. And when you play with it, if you need to turn around, you not going up or down, but just rotate. You quicken two that rotate clockwise, you slow down another one, and then it starts rotating as a whole. So there is a connection analogy to like atom with several electrons that rotate, or electrons that have internal angular momentum. It's just entertaining picture. I regret that I didn't draw the demonstration. Otherwise, we could have fun. So the simplest rotation along this paradigm, along this line, is when the direction is along our preferred z-axis, rotation x1 y plane, and for rotating diatomics or physical rotation, we did found that there is a quantum state with no rotation at all, analog of s orbital, and then there is a minimal quantum of rotation. But if we would look on the electron, I'm going to postulate something instead of deriving. The state with no rotation is absent for this object. So, but there are only two states of internal rotation. One is clockwise, another is counterclockwise. You cannot spin it quicker or slower because the total amount of energy associated with this internal rotation is fixed. So from previous statement about changing the length of vector and orientation, for spin, you can, for internal rotation of electron, you can only change the direction of a vector, but not the its pace. What does it mean? I am going to become happy. I don't know if you will share my happiness, but from complicated enough subjects, we are coming back to the area where rigorous and relatively simple math can be applied again and followed in all details. Although we will not do it in the class here because of lack of time, but it is possible. So if there are only two permitted directions, it means for this quantum object there are only two states. And it's not good to tell about this clockwise and counterclockwise rotations in public. It's better to say just internal degree of freedom is two quantums, with two states. So it's I probably need to cut this part from the recordings. But there are only two quantum states. You can call them up and name it with direct notation, and down. Or people name it creatively like alpha, or they call them plus 1/2 or minus 1/2. But it is just two states for the speed. So it means that to some sense we already know the eigenstates, but we don't know eigenstates of what? Probably of the operator of total angular momentum, of the z projection of angular momentum, and maybe of Hamiltonian. But whatever we do, whatever relations between these two states are, the basis for describing of the spin has only two states. So any quantum state in this basis is represented as vector with two components. For a vast majority of our time we wasted in the class, or maybe not wasted, maybe enjoyed or did something helpful. We were considering the infinite numbers of degrees of freedom. When you were doing your projects, you took the x-axis, you discretized it onto 100 or 200 steps, and in order to describe, to determine the wave function at a given time, you were providing probability amplitude, the psi function at each point of space, right? And if you want to be absolutely precise, we need infinite number of such points for a continuous degree of freedom. For speed, like if you have continuous x, you have infinite number of discrete points. But for spin, our space consists only of two states, two basis states, not infinite, but only two, which can be named along this ways, like alpha and beta, plus or minus, plus 1/2, minus 1/2. Right? So any wave function that relates to the spin will be recorded as psi equals expansion coefficient in front of first basis state, alpha, plus expansion coefficient in front of the second basis state, beta. So right now, we even not touching whether those are eigenstates, but each state will be a superposition of this rotating clockwise and rotating counterclockwise. This is so nice if we foresee necessity of doing something by pen and paper. So it is the simplest possible class of problems in the whole modern science. So last time I seriously faced vectors of dimension 2 was last year of middle school with vector addition, right, x and y, or maybe first year of high school. Now we are coming back to this level of complexity. So quantum state, just two projections, two numbers. And then one applies all machinery and all paradigms of quantum operators. So many, if you ever need to teach quantum, many textbooks start with the spin because mathematically it is the simplest problem. I do not welcome this idea because it is a little abstract and it may kill enthusiasm. Well, you can kill enthusiasm anyway, even with other systems, but I think it is too abstract to start with. So, but technically, we could wipe off anything we did before and start quantum and physical chemistry from today. So it is another entry in the building, and you can climb up to the same level of development. Bored. So what do you do if you are exposed to quantum system and you know that you need to establish connection with real world, you need to find some of its properties, you need to tell something about it. What do we do?
Find the Hamiltonian?
Yes. Yes.
Favorite answer.
It's a universal answer. How do you find, let's discuss how can you find Hamiltonian for spin? Do not be surprised. It's a big challenge. I do not know. I wouldn't say that I do not know the answer, but I do not see a straight path to it. It's counterintuitive and not logical. One could start. Scroll back from total value of angular momentum and try to do some tricks to express amount of rotation, and then express rotation along x, y, and z axis, add them together and consider it as Hamiltonian, which would be right. But there is another way that brings us through our favorite philosophy of bypass, which may look not very logical at the first, but then it shortens the way to the answer. So, what are your favorite operators regarding the harmonic oscillator?
The ladder operators.
Yes. What do you think I will tell next?
There's ladder operators for spin.
Yes. So, and if you do have two states, and I'm not putting this as an energy axis, just two states. So we can introduce the operators that you pump it from one state to another and back, right? Let's just chew this idea and see the consequences. I promise it is the shortest way. And again, do not take it too much seriously. There is no time for rigorous. And my goal is to entertain you. Right now, there is no time to derive things, and there will be no homework on this. Pure entertainment. Vector. So quantum state is alpha c beta. So if the system resides in state alpha, how would we record such system in the basis of this two-component vector? What will be the value of projection C alpha and C beta? C alpha equals C beta equals
1, 0.
Everyone agrees, right? It's nature. 1, 0. What if the system is in beta? Then wave vector will be 0, 1, right? So we didn't move anywhere towards real world, but we already have mathematical tools to deal with spin. Right? So we have quantum states, basis vectors in discrete form. Not abstract, but discrete, in form of matrix. Now, if you do have raising and lowering operators, that raising is plus acting on alpha will make it beta, and lowering S minus acting on beta will make alpha. Right now it is abstraction. But if you want to go from abstract space to something that we can touch, maybe not in real life, but in virtual space. If the quantum state is a vector, then operator should be right? So the question is which matrix represent S plus and S minus. So we will want to construct such matrix that will convert this vector into this vector and otherwise. Any ideas how such matrix may look? If you know, stay happy. If you do not know, just try to concentrate for your pleasure. So the elements are either 0 or 1 here and there, right? So elements of matrix that will convert between these vectors will also need to be either zeros or ones. The shape of the matrix can be guessed, can be generated from practicing row by column matrix multiplication. And we are switching between different rows. So we need to find such matrix that multiplying by this this column will generate a state with 1 on the top and 0 in the bottom. I don't know how to split it onto subtasks, but and when I was in the 3rd year undergraduate, I also was very upset on the instructor because it was presented as the like, here is a problem, here is the answer, but how do you get through it? Probably one needs to write a matrix 2 by 2 with unknown coefficients and plug it into these definitions and then solve for it. But if you do know the answer, you do not have patience to wait. So let's just check. Row by column. Row by column will give 0, right? Row by column will give 1. And inverse. Row by column gives 1, row by column gives 0. So it is a matrix 4 by 4 with 1 element equals to 1 and 3 elements equal to 0. Make sense? No need to memorize, no need to practice. There will be no assessment of your memories and skills on this. It's just for your play. Row by column. So we do have 2 matrices, S plus and S minus. Ladder operators. They will convert whatever was in one state into another and back. Okay. Let's go further onto non-logical, counterintuitive way of bypasses and follow the same counterintuitive logic as we did for harmonic oscillator. What can you do? What can you practice if you did define an operator? So there are 2 approaches to quantum theory. One is do anything for beloved wave function. And another, but anything we do has a target to predict observables. And another one is forget about function and do everything for expectation value or for the operator. Right? So there is a Heisenberg equation of motion, and there is a natural wish to solve Heisenberg equation of motion for any operator. So if we do it, it will make the achievement of remaining goals much quicker and more logical. For lucky you who are in this class, it is not as new, not as challenging, because we went through this path for harmonic oscillator. We knew that one can solve Heisenberg equation of motion for raising lower operators, and then, upon solving for them, one can set up linear combinations of these solutions, and then come to something truly observable that has relation to real life. Let me offer you this path again and claim that it will be much quicker than any other pedagogical pathways. What is the energy of spin up in absence of magnetic field? How does it differ from energy of spin down in absence of magnetic field? If this question challenges you too much, let's look around for educated, certified physicists.
What was the question again?
Is there energy split between
You took my invitation to sleep and relax too literally. So don't openly ask them. They should have made their homework in their classes.
degenerate?
You know, degenerate. Yes, correct. Well, can you say in different words?
It should have the same energy because there's no acting forces.
Right.
There's nothing to.
So, if we do not have anything acting on the rotating internal degree of freedom of electron, whether it rotates clockwise or counterclockwise, where its in degree of freedom has plus 1/2 or minus 1/2 projection, the energy will be the same. How does this information prompt us to set up a Hamiltonian? It means that Hamiltonian is typically diagonal, right? I have a better idea and more logic. By analogy to our two-dimensional rotator, what is the energy the waiver does commute this total angular momentum squared? So the length of the vector of angular momentum. And we do know that the length of total angular momentum for spin by our axiomatics, by our definitions, doesn't change. So we can set up this total angular momentum squared as, I'm skipping the factors, 0, 0, 1. So an identity operator that doesn't change anything. So whatever our spin state is, it will be not affected by the by either Hamiltonian or total angular momentum operator. This is sufficient input to practice Heisenberg equation of motion. This is cool, but not enough. I went too quick because of time. So here is my goal is Heisenberg equation of motion. But before I do not destroy it. Just at a little slower pace. Summary of what we have told. One state represented by this value, another state represented by this value. The Raising operator can be expressed either as a matrix or in Dirac form as we always had, cat times bra. So it removes beta, creates alpha, and opposite S minus removes this alpha bra and generates beta cat. And the thing that I did skip, the components of the total angular momentum or Hamiltonian operators, to get one on the diagonal, one can keep the same cat and bra. One can multiply the S plus to S minus and S minus to S plus. I want to go to Heisenberg equation of motion very quickly. But this basis of the operators gives a way to formulate Hamiltonian of these two level systems. So this writing energy of 1, energy 2 is energy of first state multiplied by this projector, energy of second state multiplied by this projector, or it can be expressed by energy of these two products of raising moment operators, or this energy multiplied by projectors. Right now, we do not need it. Those of you who did Marcus theorem may like it as a way to express the Hamiltonian for states with several potential energy surfaces. Because on one hand, we have right now this spin, but in the future, electronic degrees of freedom, which we describe with this Dirac notation of prime cap. But at the same time, these energies of one state and another state do depend on position and act as quantum operators acting on position themselves. So we can have same kinetic energy for both, and then different potentials for ground and excited states multiplied by this projectors. So I'll try to cover it again on Wednesday. Now I'm looking for Heisenberg equation. Yes. Finally. So we compute Hamiltonian with operator that we want to propagate in time. And we can do this thing even if you didn't develop far enough in understanding what this operator is. It's universal. For any operator, you can formulate Heisenberg equation of motion and so on. So, if we formulate it for S plus, you can enjoy a lot of easy and pleasant algebra and find that it will perform same thing as we observe for raising operator in the harmonic oscillator. It will be value for the operator that just accumulates phase, which means rotates in complex plane. If the energies are not degenerate, if they're degenerate, then it just doesn't change. Please do not develop feeling of upset to me. Remember, right now I'm squeezing material of 2 weeks into 50 minutes. So if something seems not logical or some derivations are skipped, do not suffer. So if we practice the same operation for Lagrange operator, practice this same Heisenberg equation of motion for lowering operator, it will also accumulate the phase with a pace proportional to difference between this alpha and beta states. If they degenerate, nothing, there will be trivial dynamics, means no dynamics. But the sign of this phase accumulation will be different. So it's like rotating complex plane in opposite directions. Two oscillator exponentials, our favorite mathematical object. Now, door is opening and all body over entering. And tells like, hey guys, I know you do not like complex numbers. Why don't we convert it to real? So any imaginary exponential is sum of cosine and I times sine, right? And if we take this dynamics of raising and lowering operators and build linear combinations, adding or subtracting them, then instead of strange oscillator exponential, we will get just sine and cosine. Sine and cosine with a pace proportional to offset of energies, which will be zero if there is no magnetic field and will increase if magnetic field is applied. This is another statement I hated my instructor. So I know it's either too quick or not logical, but adding together these two things or subtracting them will bring us from complex plane rotation into sine and cosine. So now we are coming to a real world. And I have 2 minutes. Very good. So if you take expectation values of this S plus and S minus operators, add together, initial values, and then oscillations proportional to cosine. If I take the subtraction divided by imaginary unit, it will evolve in time as sine. So S statement, summation and subtraction of these weather operators will correspond to projection of magnetization of the material composed of such objects. So if you have unpaired electrons sitting on an atom or molecule and the values of such atoms, then adding and subtraction of the weather operators will tell us what is the internal magnetic field of such system in X and Y dimension. So if we have a little offset between their energies, then this sine and cosine rotation there is a magneton, which is a proportionality between this spin components and actual magnetic field that you can measure. Just put this magnetic material on scale and see how it acts on another magnet. And then magnetic field has 3 projections. Right? X, Y, and Z. Z projection will not change, and there is another combination of this basic operators that gives Z projection. But these 2 that we were talking about change in time as sine and cosine with the same frequency. So sine and cosine with a constant length for the same frequency is an equation of circle. Which means if you do have a system with 1 unpaired electron, you apply a little magnetic field, you make a lot of them, and then you measure magnetization. This magnetization will perform precession, proportional to the strength of magnetic field. And this effect, in our simplest case, Z projection doesn't change, and X and Y projections circle. In more complicated cases, the the tip of spin three-component vector, it forms more complicated trajectory on a sphere. This sphere has a name of Felix Bloch, and motion of a tip of spin vector on a Bloch sphere is a key to understanding nuclear magnetic resonance. Enough. Thank you for being passionate about this extremely squeezed materials. Looking forward to see you on Wednesday. Relax, accumulate strengths. I think other courses give you harder time.